Good morning, everyone. Today we're going to talk about how to simplify radicals, specifically square roots, and the different steps and strategies for doing so. So first, let's go ahead and talk about the different parts of a radical. This thing right here, and I'm going to highlight it so you can see it better. Let me go ahead and do that. Right here. This, right here, that is called a radical. That's all it's called. We're just going to put word radical here. Okay, this n right here, this is called the index. The index tells us which root we are taking. So are we taking the square root, the cube root, the fourth root, etc. Okay, and then the number inside the radical is called the radicand. But we don't usually use that word, so I'm not going to worry about that too much. If there is no index, it is assumed that the index is 2. Always 2. If there is no index, the index is 2, which means we're taking the square root. So to make this easier for us, we're going to go ahead and list the first 12 perfect squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and I didn't mean to write 84, 64, 9 squared 81, 10 squared 100, 12 squared 100, 11 squared 121, and 12 squared 144. And just in case you want them, 13 squared is 169, and 14 squared is 196, and 15 squared is 225. Those are actually some that we might use. So it's easy to do the perfect square roots. We do need to remember that for every square root there is both a positive and a negative answer. And the reason for that is negative 4 times negative 4 equals 16. Positive 4 times positive 4 is also 16. So for our perfect squares, our answers are going to be plus or minus. So we're going to go over here to our symbols. 4. Positive or negative 4. Generally speaking, we will go ahead and stick with the positive root, and that's because we're working with positive numbers, distances, and such. So number 1 was fairly simple. Square root of 16 is 4. Now we have number 2 says 2 times the square root of 121. So what we're going to do is we're going to make this 2 times the square root, and that is over here in our symbols. Here of 121, and that's going to be equal to 2 times 11. The square root of 121 is positive or negative 11, which means that our answer is going to be either positive 22 or negative 22. Now on assignments, I am perfectly okay with you leaving them as positive, and in fact from now on I will be leaving them as positive. Now number 3, we have 6 times the square root of 289. And I don't know what the square root of 289 is off the top of my head. I believe that it is 17. But let's go ahead and get a calculator just to double check our answers. It is 17, yes. All right, so this is going to be 6 times 17. And 6 times 17 is going to be 102. And again, right now I'm just going to go ahead and leave the positive answer. All right, number 4 is 3 times the square root of 400. The square root of 400 is 20. So that means the answer is 60. So how do we do this if the square root is not perfect? Because if look here, we have the square root of 32. When we take the square root of 32, we get 5.6568, 54249, da 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 da. And that's because non-perfect squares are what we call irrational. Their decimals will never end. So what we're going to do is we're going to break down these radicals in order to make them easier to work with. So what we're going to do first is we're going to list the factors of 32. So we have 1 times 32. We have 2 times 16. We have 4 times 8. And then what we're going to look is we're going to find the largest perfect square that it is divisible by. And in this instance, it is 16. So the square root of 32, and we're going to write it this way, square root of 32 is equal to the square root of 16 times the square root of 2. And the reason I'm putting the square root of 16 first is that is the one that is a perfect square. So that tells me that the square root of 32 is equal to 4 times the square root of 2. Okay. Now we're going to look at number 9, or 6, sorry. And we're going to factor 180. So we have 1 times 180, 2 times 90, 3 times 60. Let's see. Okay, we have 4 and 45. And we don't have a perfect square yet. So far, our only perfect square is 4. And that's probably not going to be our highest. Okay, we have 5 times, let's see, 3, 6, 36. And when we finally get a good perfect square on the right-hand side in the big numbers, we can stop. Okay, so let's just double check. 180 divided by 5 is 36. 36 is our first perfect square on our right-hand side of the column. I said left hand, but I meant right hand. 180 is not, 90 is not, 60 is not, 45 is not, but 36 is. So we're going to set this as the square root of 180 will be equal to the square root of 36 times the square root of 5. And that means that the square root of 180 is equal to 6 times the square root of 5. All right, now we're moving on to the square root of 147. First, we're going to list our factors. So we have 1 times 147, 3 times 49, and then 7 times 21. And 49 is our highest perfect square. In fact, it's our only perfect square. So we're going to say that the square root of 147 is equal to the square root of 49 times the square root of 3, which means that the square root of 147 is equal to 7 times the square root of 3. Okay, now that's the square root strategy for taking care of these. There are other strategies. One is called the birthday cake method. It is a little more complicated as there's more work to do. But I am going to show it to you on this one right here, 175. So what we're going to do is we are going to start, and I'm going to do this on a marker board and then take a picture so I can explain it to you. One moment. Okay, so on number 8, what I'm doing is I am finding the prime factorization. That means I'm going to find all of the prime numbers that can be multiplied together to get us 175. Prime numbers are numbers that are not divisible by anything other than themselves and 1. 1 is not a prime number. So our prime numbers are 2, 3, 5, 7, 11, 13, 17. We probably won't need to go any further than that on this assignment. So in this one, what you do is you take the number that's inside the radicand and you divide it by the smallest prime number that you can. So what I'm going to show you here is that 175 is not divisible by 2 evenly. It's not divisible by 3 evenly. The first number it was divisible by is 5. So we're going to use 5. So 175 divided by 5 was 35. 35 is also divisible by 5. So we divided by 5 and got 7. 7 is prime, so we are complete there. And so how this works out is we are going to say that the square root of 175 is equal to the square root of, and we're going to take the numbers that are inside, 5 times 5 times 7. These are on the outside, sorry, on the outside of this picture. So we had a 5, we had a 5, and we had a 7. Now we're going to look for pairs. So we see that the 5 and the 5 pair up, which means I'm going to take them together out of the radical. So when we do that, what it looks like is going to be the square root of 175 is equal to 5, because I have a pair of 5s, so I'm going to bring out one of the 5s, times the square root of 7. Now that is the longer way. It works a lot well for many people, especially if you're not comfortable with your perfect squares. This will work better. However, if you are comfortable with your perfect squares, it is definitely easier if you do it with the perfect square method. So looking at number 9, we have 48. So we have 1 times 48, and we have 3 times 16, and we have 4 times 12. On these smaller ones that are only have 3 to 6 factors, it's more easy for us to break it down. So we have the square root of 48 is equal to the square root of 16, which is our largest perfect square, times the square root of 3. And then that tells us that the square root of 48 is equal to the square root of 16, which is 4, times the square root of 3. And that's our final answer. Okay. Up next, we want the factors of 54. You're always going to factor what's under the radical, the radicand. So 1 times 54, 2 times 27, 3 times 16. Let me double check. $18. Darn. That's okay. It happens. Let's see. 4. It's not divisible by 4. It's not divisible by 5. It is divisible by 6. So we have 6 times 9. And our earliest perfect square is 9. So what we're going to get for this one is we need to not lose this 2. So we're going to say 2 times the square root of 54 is equal to 2 times the square root of 9 times the square root of 6. So that gives me 2 times the square root of 54 is equal to 2 times 3 times the square root of 6. And 3 is from the square root of 9. The square root of 9 is 3. And that gives me my final answer for 2 times the square root of 54 being equal to 6 times the square root of 6. And I'm actually going to leave it there. We don't need to do well, actually, let's go ahead and do one more because I want to deal with the negative number. So let's do number 13, just so we have the negative. It's going to work very similar, but I want to keep this one short. So let's go ahead and do this. We're going to factor 28. That's 1 times 28, 4 times 7. Okay, so our highest perfect square is 4. So we're going to have negative 3 times the square root of 28 is going to be equal to negative 3 times the square root of 4 times the square root of 7. Okay. So that tells me that the negative 3 square root 28 will be equal to negative 3 times 2, which is the square root of 4, times the square root of 7. And that means our final answer is negative 3 square root of 28 is equal to negative 6 times the square root of 7. Don't forget your negatives. That's the most common error that people make, is they drop their negatives and they drop this leading coefficient. So please make sure you don't do that. All right, we're going to wrap this up here. We are not going to go on to the perfect cubes for now because we do not need them at this stage. If you have any questions, just let me know. Make sure you turn this in, and have a good day.